of ethylene glycol in presence of potassium dichromate, that is K2CrO7, as a catalyst in presence of acid to form oxalic acid, that is COH. From hydrolysis of cyanogen. Cyanogen means this one. This is the structure of cyanogen. Hydrolysis this acid HCl. Okay. Ethanol. Then what happened? Yeah, C2H5. Situation. Yeah. When esterification means what? When carboxylic acid containing compound react with alcohol. This is ROH. Now to form ester, that is RCOOR. RCOOR. Esterification. Ammonia, hydroxylic acid. 2 moles of ammonia to form isolate intermediate. Further which heating which loses what water molecules? TQ-oxamide. There are different two reaction depends upon the temperature. One is 110 degrees Celsius and there is Hello everyone, I am Dr. K. Today we are going to learn the carboxylic acid. In our syllabus, there are different 4 acids are included for the study of method of preparation and their chemical reaction, such as oxalic acid, lactic acid, benzoic acid, and salicylic acid. First we see oxalic acid. This is the structure of oxalic acid. It is carboxylic acid because it contains carboxylic acid group, that is bond COOH. Oxalic acid is also known as ethane 1,2-dioic acid. It is also known as ethane dioic acid. There are different two methods for the preparation of oxalic acid. Number one is from oxidation of ethylene glycol and another one is from hydrolysis of cyanogen. Dear students, first we see how you will prepare oxalic acid from the oxidation of ethylene glycol. First we see what is mean by oxidation. Oxidation means addition of oxygen. Then second one is removal of hydrogen. Then third one is addition of oxygen and removal of hydrogen simultaneously. And last one is the loss of electron, that is called oxidation. Here, when the oxidation of ethylene glycol with oxygen in presence of potassium dichromate, that is K2Cr2O7, as a catalyst and sulfuric acid or any acid to form our target compound, that is oxalic acid, with the elimination of water molecule. Here what happen, here is, see, this is your reactant and this is your product. In reactant, here is one oxygen and here is one oxygen. See, in product, here are two oxygen and here also two oxygens. That is in reactant only two oxygens, and in product there are four oxygens. Mean what? That is oxidation, that is addition of oxygen. This is about the first method for the preparation of oxalic acid from ethylene glycol. This is your structure of ethylene glycol. Then second method is from hydrolysis of cyanogen. What is mean by hydrolysis? Hydrolysis means it is a chemical reaction in which the water molecule split into H plus and OH minus ions, and they are taking part in a chemical reaction, that is hydrolysis. They may be acid or basic hydrolysis. Cyanogen means this one, CN bond CN. This compound is called as cyanogen. When the hydrolysis of cyanogen by using hydrochloric acid as a acid and water, then heat to give our target compound, that is oxalic acid. Here what happened? The cyanide group converted into carboxylic acid group with the elimination of ammonium chloride. This is your second method for the preparation of oxalic acid. That is when the hydrolysis of cyanogen by using hydrochloric acid, water and heat to form oxalic acid. Then we see chemical reactions of oxalic acid. There are different four reactions of oxalic acid, that is number one is reaction with ethanol, that is ethyl alcohol. Number two, reaction with ammonia. Number three, reaction with glycerol. Number four, action of heat. We see one by one. Number one is reaction with ethanol, that is esterification. What is mean by esterification? Esterification means when carboxylic acid containing compound react with alcohol, that is ROH, in presence of acid to form ester, that is RCOOR. This reaction is called as esterification. When the esterification of oxalic acid with ethanol, that is ethyl alcohol, means C2H5OH, 2 moles, in presence of sulfuric acid as a catalyst to form diethyl oxalate as a product. Then what happened? When ethanol reacted with oxalic acid, 2 moles of ethanol, okay, when 2 moles of ethanol reacted with oxalic acid in presence of acid to form ester to form diethyl oxalate. This is your first reaction. Then second one is what happen when ammonia react with oxalic acid. See, when oxalic acid is reacted with 2 moles of ammonia, that is NH3, in presence of heat to form ammonium oxalate as a intermediate, further which on heating to give oxamide with the elimination of water molecule. Okay, this is about the second reaction. Means what happen here, this OH or this OH substituted by this NH2 group. Okay, here is mistakenly O, only NH2 group. Then third one is reaction with glycerol. Actually there are different two reactions depends on temperature. One is 110 degrees Celsius and second one is 230 degrees Celsius. If we change the temperature, it gives different products. First we see at low temperature, that is 110 degrees Celsius. When oxalic acid react with glycerol, this is the structure of glycerol, is reacted with sorry when the glycerol is reacted with oxalic acid at 110 degrees Celsius to give glycerol monoformate as a intermediate, further which on acid hydrolysis to give formic acid and glycerol is regenerated. This is your formic acid. That is what happen at 110 degrees Celsius. It gives two products, that is formic acid and glycerol is regenerated. Suppose we are increasing the temperature, that is 230, then what happen when glycerol is reacted with oxalic acid at 230 degrees Celsius to form this glycerol dioxalate with elimination of water molecule. Again, this intermediate heated at 230 degrees Celsius with the elimination of CO2 gas to form allyl alcohol as a final product. This is about the reaction with glycerol. Then last one is action of heat. When oxalic acid heated at 100 degrees Celsius to form formic acid with elimination of carbon dioxide. Okay, this is about the oxalic acid. We see the method of preparation and chemical reaction of oxalic acid. Thank you.